All right, so here's our first example of partial fractions, the harder kind, because we've got a repeated term in the denominator that we need to deal with. So the way we do that is we need to break it all up into pieces, and I'm going to start by just copying it down to x plus 1. I'm going to copy it a little bit smaller so I have room. We need to set this thing equal to our constants divided by each term. So this one's the easy term, so I'm going to deal with that one first because that's easy. And then what we need to do is we are going to, this is where it changes from when we first covered this topic. Because this is a repeated term, I need to do it first for the repeat, and then I need to do it for each power that goes up. So this is squared, so I need to do it for x plus 3 squared. If this was cubed, I'd have a d term with an x plus 3 cubed. If it was to the fourth, I'd have it'd be f term, and it would keep on going up. So we notice that. Also notice that even though this is a square thing, we don't need a linear term up here. That's going to be for something that's irreducible. So this is all set. Now our job is to back solve for a, b, and c. I want to point out in some of the notes you might see, somebody might use b sub 1 and b sub 2. Just because it's b sub 1 and b sub 2 is just so that they can keep track of where they came from. It's not because the b1 and b2 are related in any way arithmetically. It's just to keep their algebra, I don't know, straight, I guess. So now our job is to start solving for a, b, and c. We need to find a common denominator just like we did before. That's a little bit trickier. I'm going to use two different colors to represent that. So if I start dealing with the a, and I'm just going to hold this off to the side. I'm just working with this. So it's a over x minus 1. I need the common denominator. The common denominator is going to be this denominator here. So I need to multiply this by x plus 3 squared. And if I multiply the bottom by it, I need to multiply the top by it. And then we do the same thing with b. So b x plus 3. And I need to pick up this x minus 1. And I need to pick it up here. I also, though, need to pick up an x plus 3 because it's an x plus 3 squared. So I'm going to square it here, and then I'm going to multiply the top by x plus 3, right? So that just made that term pretty complicated, but it's fine. And then I do the same thing with c. C is actually the relatively easy one. C over x plus 3 squared. That's good. I need to pick up the x minus 1. So now I have a common denominator. So if this big thing here the original equals this, then we can cancel out the denominators. Like that's why we do that. So that's one of those steps that once you do this a few times, you can kind of jump right to where we are now, where we have 2x plus 1 equals this a, b, and c thing. Now what we need to do is start multiplying out the a, b, and c part of this. So if I multiply this out, this is going to become x squared plus 6x plus 9. So it's going to become ax squared plus a times 6x plus a times 9. So that's that. This, I'm going to just multiply this out real quick. X squared plus 2x minus 3. So this part is going to be plus bx squared plus 2bx minus 3b. And then the c is going to be plus cx minus c. This whole thing equals 2x plus 1. So now we got to look and we got to line up the terms. I'm going to use a few different colors just to make that clear. Ax squared, bx squared. There's no x squared here, so it's 0x squared plus 0x squared. So we know that a plus b has to equal 0. That's good. That's our first equation. Now let's look at the x terms. So 6ax, 2bx, cx has to be 2x. So we know that 6a plus 2b plus c equals 2. Okay? And lastly, let's find a new color. We'll do it in purple. We know that 9a, right, this term, minus 3b minus c has to equal 1. So we have 3 equations and 3 unknowns, and we can solve these equations by elimination. I guess you could use matrices, which we haven't covered in this class yet, so I'm not going to do matrices. I'm going to just solve this and do elimination. So over here I can go a equals negative b. Well, if a equals negative b, now everywhere I see an a, I can have a negative b. So I can change this green equation to be negative 6b plus 2b plus c equals 0. And over here I can say negative 9b minus 3b minus c equals 1. I should have done that purple. Negative 9b minus 3b minus c equals 1. And I can simplify these equations. So negative 4b plus c equals 0. I'm going to need to also substitute again. So I'm going to say in this one that c is 4b. Right? So I've done my one substitution, and now I'm doing another substitution. C is 4b. So if c equals 4b, I can put 4b here. So I know negative 9b minus 3b minus 4b has to equal 1. 9, 12, 16. Negative 16b equals 1. B is negative 1/16. If b is negative 1/16, I can come over here, right? I can come over here, and I'm going to draw an arrow and come back up here and say that, therefore, a is positive 1/16. If b is negative 1/16, then we know that c equals 4 times negative 1/16, or c is negative 1/4. Whew! That was a lot of work to get to those values. But now that we're there, what I'm going to do is rewrite this equation. I'm going to erase it and rewrite that integral expression, because what we've come up with is our equivalent integral expression. So what I had there, the integral of this, is really now the integral of 1 over 16 over x minus 1, plus the integral of b, which is negative 1 over 16, over x plus 3, plus the integral of c, which is negative 1/4, over x plus 3 squared dx. Phew! This is an easy integral to solve. Maybe you should hit pause and give it a try, but this is an easy integral to solve. So what we should remember is the integral of this over just a single linear term down here means that this is really going to be 1/16 ln of x minus 1. Plus, same thing, linear term, no problem at all, negative 1/16 x plus 3. Whoops, ln x plus 3. This term might look tricky, but it's actually super easy. Pardon me if that got messed up. This term here, if we look at this as a negative 2, right, is a power of negative 2, this actually becomes plus 1/4 x plus 3 to the minus 1. And if this is a little tricky for you, just remember if you did use substitution, you might be able to get it, but I can prove that it is correct by taking the derivative. Negative 1 times 1/4 is negative 1/4. That stays the same, and that goes to the negative 2, which is what that is. So it's done. That's how you can solve these problems. The calculus is easy. The algebra is tough. Good luck.